Hey guys, how's it going? This is Siri, and today in this video we're going to take a look at qubits. It's just going to be a gentle introduction to qubits and sort of analogous to bits you might have heard of. If not, that's perfectly fine. We'll talk about that in this video as well. So in the last video we left off at what the different how quantum computing is really different and compared to classical computing and classical computers. And one way in which we said that they were different is the way in which they compute things, their computational approach, right? So before we talk about how we compute things, let's talk about what a computer actually is, right? So a computer, right, we have some inputs, right? It goes to a computer. And then what do you get? You get some output, right? Basically what a computer does, right? In any sense, whether it's whether you're literally typing in code or you're Google searching something and you get some search results, right? Literally anything you do, you're clicking on a show and you get some output, right? You type in something and you get an output, or literally anything, right? Input, computer, and then output, right? How does it do that? Well, your input is in, language that you understand, right? You understand what you're inputting in, but the computer doesn't know that in the form that you say it or the form in which you input it. Rather, it takes what you input and then it converts it to zeros and ones, 0, 1, 0, 1, 1, 0, 0, 1. That's how it speaks, right? That's how it communicates. That's the only thing that they understand, right? Binary, right? 0 and 1, right? And so whenever you input something, it turns it into binary, and then it gets another binary output, and then it turns it into something that you can understand. Okay? So that's that. And so classical computers, right, which is basically what we have today, right? Classical computers, anything that's not quantum computers, right? Classical computers, or maybe not anything, but the ones that we use today. Classical computers, right? We have zeros and we have ones, right? What do we call these? We call these bits. These are bits. And so a bit can be either a 0 or a 1. And so 0 can be thought of as a switch that's, turned off, right? A turned off switch. Okay? And, a 1 can be sort of thought of as a turned on switch. Switch that's turned on. Okay? And so in classical computers, right, it's only logical to us that a bit can either be a 0 or a 1. It can't be half on and half off, right? You can't it's nowhere in the middle, right? It's either a 0 or it's either a 1. Or you can't have a 0 and a 1 at the same time. It can't be on and off at the same time, right? So now we go to quantum computers. Okay? What do we see here? Well, what we see here is that, just like we have bits in classical computers, right? The way we store information and process that information and use that information and turn that information into something else that's very useful, right? Basically data, right? So we also have something like bits, but not exactly like bits, right? We have qubits. We have qubits. Okay, and so what do qubits do? they also store information, except they store information in quantum computers, right? And so just like classical computers, we can have a 0 and we can have a 1. But the interesting thing is that we can also have a combination of the two, okay? It can be a 0 and a 1 at the same time. And, we sort of have to deal with probability, right? So it's not just black and white. It's not just on and off, right? We can have a combination, right? We can have in probabilities, right? Speaking in terms of percentages, right? We can say that we have 40% 0 and 60% 1 or something like that, okay? So it's a way to store information, right? And it actually makes things a lot faster because it can, process information quicker, search through solutions quicker, right? That's one advantage we have with quantum computers and with the idea of qubits and with the idea that it's employing here, which is superposition. And, we'll employ other things too, right, when we're studying gates and, different kinds of algorithms. But just this video is meant to be an intro to qubits, what is a qubit, and things like that. Okay? And so, like I said in the previous video, right, we can solve some certain kinds of problems with quantum computers. And the way in which they solve these problems is also very different. Okay, and so let's do a table. Okay, let's do a sort of comparison, and we won't be able to understand this so deeply right now, right? We can have a general intuition at this point, but to really fully understand it, we would have to get into each of those topics and dive deeper into them, which we will do, just not in this video. Okay, so we have classical computers, right? And we have quantum computers. Okay, so we just talked about how classical computers use bits and quantum computers use qubits. Okay? 0 and 1 are what we call discrete states, right? Different states, right? Two discrete states. We call these states. Two discrete states, but in quantum computers, we don't have discrete states. What we have instead is not discrete states. We have they can interact with each other, right? The states, let's put it that way, the states can interact with each other. Okay, you can add them up, they can cancel out, right? We have this sort of interference concept from quantum mechanics showing up here. States can interact with each other, and we can have combinations. Okay, wait, they can interact with each other, but the pair here is that we can have a combination. Okay, that's what I wanted to say. Right, combination, we have a combination, and here they do not interact with each other. They're discrete entities, 0 and 1 in classical computers do not interact with each other. They're independent. Okay? And so the last property that I wanted to talk about, which is very important, is the deterministic nature of classical computers. or deterministic nature of classical computers versus the probabilistic nature of classical computers. Right, and we've got a taste of that here, right, when we said that something's like 40% 0 or 60% 1, and we'll make it a little more concrete in future videos. But, you know, this is sort of like a chart that sort of like, you know, looks at the differences between classical computers and quantum computers. And, you know, these things, even though they're only 4, they can go a long way, and they can have intense and immense applications in future algorithms that we will discuss later on, and basically like the future of quantum computing, right? So I think that's it for this video. Yeah, it was an intro to qubits, basically like bits, except we can have zeros and ones, you know, together, and sort of like a table comparing the two types of computers. All right, I think that's it for this video. Thank you so much for watching, and I'll see you guys next time. Bye.